name is Tim Bailey. I am a data scientist with the Management Performance Hub. I mostly work in the education and workforce development space, but today I'm going to be talking to you about a project I undertook with the Department of Local Government Finance in 2019 and 2020. Building a Shiny application user interface to standardize business processes and improve efficiency. So a little background, the Department of Local Government Finance conducts an annual ratio study. I'm going to be talking about the inconsistencies and inefficiencies in dealing with messy, unstandardized data input for standard business processes. Problem specific to the ratio study, there was a high cost of entry in order to run the application, needing to understand code. And then I'll talk about the solution built. So the Shiny user interface, what is Shiny, why use it? I'll go through a simple example. I'll provide a demonstration of the application, and then I'll provide some resources around open source available property value data, and summarize everything I've talked about. So I'll start by saying I am not a property tax expert. I am also not a ratio study expert. So if you have questions around property taxes, property value assessments, or ratio studies, I'll kindly refer you to either your local county assessment office or the Department of Local Government Finance, depending on the question. So what is the ratio study and why does it matter? Property tax is the largest source of revenue for the state, with almost all proceeds going to fund local government. Funds are used to pay for a variety of services, including welfare, police and fire, new construction and maintenance of buildings, local infrastructure like highways and roads and streets, and operations, including salaries of local units of government. So you can see there's the breakdown of what each property tax dollar goes to. You can see the bulk, almost 50 cents on the dollar goes to schools, but really important critical stuff. And so if you have inaccurate assessments, you're missing out on funding. And on the other side, you may have angry property owning taxpayers who may have overpaid. So the DLGF conducts an annual ratio study to measure the accuracy and equity of assessments. The ratio is actually defined as the assessed value of a property divided by its sale price. And by law, the assessment ratio for all properties in Indiana is to be 100%. Two tendencies of assessors that the ratio study is looking for with descriptive and test statistics. Sales chasing is the practice of using the sale of a property to trigger real appraisal of that property at or near the selling price. Subtle, possibly inadvertent variety of sales chasing may occur when the recorded property characteristics of sold properties are differentially changed relative to unsold properties. All that essentially means that the assessment ratio is statistically different between sold and unsold properties in a given neighborhood, and that is an indicator of sales chasing. And then it's kind of just human nature to underassess the value of low value properties and overassess the value of high value properties. So that is another thing that the DLGF looks for statistically. All right, so I'm going to talk about problems generally in terms of business processes, and then specific to the context of the ratio study. So when you're working with manually generated Excel files, common problems, duplicate records, missing values, record disagreement, file and column name inconsistencies. And if you've ever worked with dates in Excel, you know the nightmare that exists there. Manual processes for cleaning and standardizing data leads to time-consuming cleanup, work, and rework. Uncaught or caught too late erroneous data, and process inconsistencies. So the DLGF, they conduct this ratio study assessment for all 92 counties within the span of a month and a half. They had previously been manually cleaning and standardizing data using SPSS software. So manually cleaning with Excel and then using SPSS software to run descriptive and test statistics in order to send back the submission to the county assessment offices. The Mann-Whitney U-test is one of the tests they run. Like I mentioned, looks for a significant difference between sold and unsold properties. Some large counties would have upwards of 150 neighborhoods fail this test, and it would take the DLGF about 3 days for assessors to work together to pull the fail neighborhood data from the SPSS software one by one. Then they would actually conduct the review. If by chance there was a data quality issue found, then they would have to repeat that process. So now, with this new solution of the Shiny application, they can run the Mann-Whitney test with a few button clicks, and it takes seconds to export the failed neighborhood data, no matter the size of the county. Data quality errors can be diagnosed accurately and specifically long before running the Mann-Whitney test, using functions, again, controlled by click of a button. So more generally, before any statistics or more interesting analytics can be generated, data must be cleansed and standardized. This process is common to almost all business operations. It's time-consuming and costly. If an issue or an error in the data is not caught, they say that data scientists may spend up to 80% of their time actually cleansing, standardizing, and manipulating data. And that time could be better used analyzing, visualizing, modeling, all of that. So standardized functions for ingesting, cleansing, testing data for expected truth with an easy-to-use interface can save hundreds of hours and easily catch errors that may have gone uncaught. Automating this burdensome work frees up employees to do what they do best, which is think and analyze and do more valuable work. So the evolution of the ratio study code, as I mentioned, it was originally run in SPSS software, and then the evolution went to an R Markdown notebook. If you're not familiar with those, it's essentially chunks of code. So you run a chunk of code and then you get output. You can see what the output is, and then you run another chunk, and it's all visible. So when I mentioned high entry cost, that was it, right? So you have to be familiar with code. You have to be comfortable running code in this notebook format. So the next evolution was to put all that code behind a user interface in the form of the Shiny application. All right, so I've been talking a lot about Shiny. Let's actually say what Shiny is. So it is an R package that makes it easy to build an interactive web application straight from R with no web development skills needed. It combines the computational power of R and Python with the interactivity of the modern web. So for me, data scientist, definitely not a web developer, it's great because with a few lines of code, I can create a user interface to allow users to interact with models or visualize data, explore data, see the insights that I'm seeing in the data. So why I should use it? So we can build user interfaces with simple and succinct code, as I mentioned, and then standardized processes with scripts. And we can build upon the shoulders of giants with all of it being open source. So this is a as simple as possible example of the structure of a Shiny application. So the first thing we do, we load the package with the library call at the top, and then we actually define the physical structure of the application. So the UI, we're putting in a header panel, calling the application miles per hour. We see a sidebar panel. We can create inputs for the user to give us input data, and then we have a main panel, and that's where we can display our output. And then the server function is what ties it all together. It takes input and it spits out output. So that's where we would do things like manipulate the data, visualize it, model it, run tests, et cetera, et cetera. And then the Shiny app function just ties the two together. So this is what the landing page, homepage of the ratio study application looks like. You can see it's split into 4 different applications at the various stages with a description of what they each do. Um, so I'm going to go ahead and run through a quick demonstration. So we'll go to our first application. And the first thing in all applications is to define the county for which you're running the application uh, and the year in case you ever need to run previous years. Um, So we'll first load our sales data. These are fixed width files that come from another division within the DLGF and contain all sales for a given county, which is recorded in their system. So we see some information, a pop-up, how many sales there were in the county and how many potentially valid sales for the study submission. We see a preview of the data. We can do some things like show more of it, scroll through. We could filter and search for a specific parcel number, or this is essentially the ID for a sale if we had specific concerns. And then we can do things like generate files. So we generate a explanation file sent out to the county. I'm not going to get too much into the business logic, just talk more through the functionality. So you see we click the radio button and now we have more options. We can load in more data. So we'll go ahead and do that to demonstrate the data quality checks. So once we've loaded our data, we get a little nice progress bar telling us when it is complete. And it takes a bit just because this is Allen County, which is one of the larger counties in Indiana. And so we can start doing things like check for multi-parcel sales with multiple sales date, which should not be multi-parcel sales without a primary parcel. And we're in luck because in this specific county, those issues do not exist. We can check for duplicate parcels and everything's looking pretty good so far. But let's look at our workbook and we can check for missing values, and we see an instance of one parcel having a blank cell for assessed value or property class code. So we can go ahead and download that data, open it up, take a look, and then the DLGF assessment rep could go ahead and just send out this file and say, hey county, can you please fill in the missing value here? We don't know what it is. All right, so then you can say check for discrepancies between these two files, right? So match on the parcel and then say, oh no, there is a value that is different between the two. Let's go ahead and reconcile that. Again, send it to the county and they can tell us which the correct value is. All right, so we can go ahead and move on. We say we've gone through, checked all of our data quality, reconciled it with the county. Now we have a clean file, and we'll again load that. So we specify our county, load our data. I'll just go ahead and hide the preview. So this application is used to generate descriptive statistics reports that the DLGF analyzes and shares within the department to executive levels and within their teams. So we can generate some comparison statistics. I won't get into these, but these are essentially assessed value specific statistics that are meaningful to the department. And then we can generate assessed value comparison detail tables So these are a little bit easier to interpret, just a total assessed value for the prior year, broken out by township, and then the current year, and then what the percent change is. And then the conditional formatting is just any absolute value percent change more than 10%. And they're also broken out. There's a table for each property type. So commercial improved, commercial vacant, residential, etc. So we can check that as a rep, assessment rep, and then we can also go ahead and download the file as a PDF. And share it with anyone. And then if we my computer's going to open it. All right, so there it is, the same thing in a PDF. And then we could download as an Excel file as well. And we get a nice tab for each of the different property code. All right, so we'll move on to the Spearman ranks correlation test. And this is the test used, as I mentioned, to look for underassessing low value properties or overassessing high value properties. So we're essentially just looking for a statistically significant linear trend over the assessed value. Again, we'll load our example Allen County data. And we just need the ratio study data here. We can run our test. We see that 3 groupings failed in this county, and we can see visually the data points plotted with the ratio and the assessed value. So you see this trend of low value properties having a low value, high value properties having a high value. And then we could also download the failed grouping data as well. So again, there's a lot of business logic baked into this that's specific to the ratio study process that we're not going to cover, but just want to show the general functionality here. And so this last application is for running the Mann, Whitney, Wilcoxon U non-parametric test. So once we load our data, we see some summary statistics. We're testing between sold and unsold properties. We'll go ahead and hide all of that and just go straight to running our test. And you saw how quickly, just in a few seconds, we get a score of 76%. So roughly 70 neighborhoods failed the test. We can go ahead and load that data in summary format, or we can load the row level data for the failed neighborhoods. Again, this is just a business logic specific that the DLGF utilizes. And then we can do some interesting things like visually inspect the data and kind of look at those differences between sold and unsold. Takes a load, again, working with a larger county, it takes a minute to load here, but we see some nice visualizations. That's obviously, so we can change the bin width, choose a different, we want to filter by township, and then choose a township, and you can see the sold and unsold. Great. So that is the application. And obviously that was a lot more than just Shiny utilized to build that. So I have a list here. I'll just quickly run through some of the major ones. Data table is a great package for data manipulation, efficient, nice, succinct syntax. Stringer for string manipulation, some logging packages, and then these ones specific to Shiny. Shiny.js increases the capabilities of Shiny through JavaScript without actually having to write JavaScript. Shiny LP allowed me to create the landing page or home page for the application with very little code. And then the reading and writing of Excel took a handful of packages, and the reason I had to use multiple, again, trying to corral the various date formats and read them in consistently and reliably. Also, some packages for working with dates, and then data visualization that was done using ggplot, scales, Plotly for the extra interactivity and tooltips, and then grid extra and conditional formatting, cond format allowed me to create the tables with the highlighting or conditional formatting. So all of that added up to pretty great impact. The DLGF measures the days from the county submission to when they've successfully passed and can send back to the county. So you can see the mean days and median from 2019 to 2020 and 2021, as well as a box plot. So you can see the steady from 2019 to 2020, switching from SPSS to R, and then a more significant drop in all measures of time to completion in terms of days in 2021. So they had some great things to say, and it essentially sped up their process and helped with the headaches of the manual work that they were previously doing. All right. So, summary: standardizing the process of cleaning and standardizing data saved them time and headaches. Low-code user interface was built with the RShiny package, and the ultimate result of all of this is more prompt and accurate evaluation of property value assessments, which in turn leads to more accurate assessments for property taxpayers, which is a good thing for all Hoosiers. So if you're interested in digging into the data a bit more, it is publicly available in a few places. So the Indiana Geographic Information Office hosts a site called indianamap.org, and there you can find the 2020 Indiana parcel boundary data. There may be 2021 available at this point, I'm not sure. 2021, excuse me. And then Indiana Parcel Assessed Value Search is available through Stats Indiana, and that is maintained through the Indiana Business Research Center, the IBRC. So you can search for individual assessed values, and then sales disclosure data is also available through Stats Indiana, and that is provided by the DLGF. Thank you very much. Here is my contact information. Please feel free to reach out with any questions you may have. Happy to help. And then there is the Indiana Management Performance Hub contact information as well, along with a QR code to sign up for our newsletter.